Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. In this video, we're going to take a look at how to add and subtract rational expressions involving different denominators. So let's go ahead and get started. So, you guys know that our rational expression is just, P over Q, okay, with the assumption that Q does not equal 0, like so. And so what we're going to do here is we're going to deal with rational expressions that have different denominators. And so we looked at this in a prior video where when you're dealing with different denominators, you have to find the least common denominator. But let's go ahead and look at a problem first to see if we can make this clear. So first one's going to be addition. 2 over x minus 2, 5 over x plus 3. And so we have to find, now this is a very basic, simple example, by the way. We have to find the factors for x minus 2 and the factors for x plus 3. Again, this is not too difficult. So for x minus 2, the factors are x minus 2. You can see, not that exciting. And for x minus or x plus 3, the factors are going to be x plus 3. So this means that our least common denominator, again, not that amazing here, is going to be x minus 2, x plus 3, because there are no other factors basically in this particular example. So when you have this information, it changes what the denominator is going to be. So our new denominator is going to be as follows. With our new rational expressions are going to be as follows: 2 over x minus 2 in parentheses x plus 3 plus 5 over x minus 2 x plus 3. That's what we have here. Now there's one thing. In each of the denominators, there's something new that was not there before. So in our first one with the numerator of 2, this new value x plus 3 is here. So whatever you do to the bottom of the expression, the rational expression, you must do to the top. So I have to add x plus 3 up here, because the x minus 2 was already there if you look at the original expression here. Now for our second example, it's kind of the opposite. This time it's the x minus 2 that is new. And so we put that here in parentheses like so, because the x plus 3, as you can see up here at the top, was already there. Now it's just a matter of simplifying things, and we get as follows. So 2x plus 3, if I simplify that, let me see here, I will get 4x plus 6, 4x plus 6, and then I have a plus here, and I'll have 5 times x's, so 10x, 5x minus 5x minus 10. Oh, excuse me, I made a mistake here. Let me fix that. This is not 4x, this is going to be 2x. I'm sorry about that. So let's see here. Excuse me, little mistake here. What I really need is I need a 2x here. I made a mistake there. Sorry about that. So I have 2x because 2 times x is going to be 2x. So this is our top right here. 2x plus 5x, 2x plus 6 plus 5x minus 10, all over x minus 2, x plus 3. And so what that simplifies to is very simple. 2x plus 5x is going to give us 7x. And 6 plus negative 10 is going to give us negative 4. All this over x minus 2, x plus 3. And so that is how you would address this particular problem. You went through all the steps, and you can see that we have our final answer there. Now let's do one example involving subtraction and something that requires some sort of factoring as well. So here's our next example here. We have 2x over x squared minus 4, and then subtract that from, or find the difference with 1 over x plus 2. So you know what we have to do? We have to find the least common denominators for x squared minus 4 and x plus 2. So when we do this, we get the following. So for x squared minus 4, the factors basically are going to be x plus 2, x minus 2. Now, for our second denominator here, x plus 2, well, it's very simple. The only factor is going to be x plus 2. Therefore, using our understanding of factoring, the least common denominator is going to be x plus 2, x minus 2. This is our new denominator. So this leads to the following rational expressions. We still have 2x, and over 2x we have x plus 2, x minus 2. And then subtract, and then we have 1 over x plus 2, x minus 2. Now there's something a little bit different here. In this example right here, x plus 2, x minus 2, this was already in the original denominator. In other words, we don't have to do anything to the numerator in this particular situation. However, for our second one, we have our x plus 2 here. That is represented here, which means that we have to bring up the x minus 2. This is what's going to be new in this particular situation. So what do we end up with? We end up with 2, excuse me, let me give you a slightly different color here. 2x minus x plus 2. How did I get that? It's very simple. Minus 1 times x is going to give me minus x, and minus 1 times minus 2 will give me positive 2. All this is going to be over x plus 2, x minus 2. When I simplify the top, now watch this very, very carefully, I get x plus 2 over x plus 2, x minus 2. Now I can further simplify this. If I address right here the x plus 2 and the x plus 2 right here, it becomes 1, and I end up with 1 over x minus 2, like so. And that completes the process. So this is an example using subtraction with where you have to do a little bit of factoring. So let me go back and recap what we did before I conclude the video. So what happened here in this particular video was we were learning how to add and subtract rational expressions when they have different denominators. In order to do this, you must find the least common denominator for each rational expression. And so we worked out how to do this in this example right here. This is our least common denominator as we found earlier. And then this least common denominator becomes your new denominator. Now, whatever was not present before in the denominator must also be represented in the numerator, because whatever you do to the bottom, you must do to the top. That way, everything stays balanced. And so that's what we have here. So we had an x plus 3 at the bottom. We got to put that at the top now. X minus 2 at the bottom, had to add it to the top here. And then it's just a matter of course, distributing, whatever constants you may have or whatever you might have outside the parentheses, and then you just add up or simplify the values as shown right here in the screen at the bottom here. Not that complicated once you get past the factoring part. And of course, this same idea applies when you're subtracting. There's nothing new here. We first found the least common denominator, as you can see right here. This became the new denominator, obviously. And whatever was new information for that particular rational expression, you also have to put it in the numerator. Now in this example, the x plus 2, x minus 2, that was already present in the original denominator. So there was no reason to add anything. However, for this particular rational expression to the right, the x minus 2 was new. It was not present before. You can see right here, x plus 2. And so we had to, of course, represent that in the numerator. Then, like I showed you before, it's just a matter of combining like terms. And in this particular situation, we had to simplify and reduce something. And having done that, you've completed the task for these two problems. So I hope that this video was useful for you and you were able to understand what we were talking about and how we addressed dealing with adding and subtracting rational expressions when they have different denominators. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.